Hello everyone, my name is Cecilia Hernandez and today I'm going to show you how to work on two problems of stoichiometry.
Was everybody's disapproval? I should have worshipped her sooner. If the heavens ever did.
Number one with this problem is to balance the equation. So they give us step 1. We know that we have carbon 3, oxygen 8, plus hydrogen 8, oxygen 2, and the other side we have carbon dioxide plus water. So we don't have the same amount here as in the amount we have here, so we have to balance the equation. So we are going to extract the numbers. We have carbon 3, hydrogen 8, oxygen 2. In the other side, we have carbon 1, hydrogen 2, oxygen 2, oxygen 1. So we have 2 oxygens, but don't worry about it right now. Now we have to find a way to make these balanced. So we're gonna add a number 3 here, which will make carbon have 3 and hydrogen and oxygen will have 6, because you have to multiply this number by the ones we have here. So here we have an imaginary 1. Now we are going to add a number 4 here that will make hydrogen have 8. So we have carbon the same and hydrogen the same now. But now we're going to we have that here we have 4, so you have to add these and then we'll make 10, but here we only have 2, so we're gonna add a number 5 here and that will make oxygen have 10. That is the first step here. Now we're gonna go to the step number 2. They are asking us how many grams of carbon dioxide can be produced from the combustion of 3.65 moles of propane. So we are going to do step number 2. Step 2. So they are asking us how many grams of carbon dioxide can be produced from a combustion of 3.65 moles of propane. So we are going to write 3.65 moles of carbon 3, hydrogen 8. As you can see, is the same one as we have up here. This one and this one. Now we are going to use the one we have here, and you are going to multiply it by 3 moles of carbon dioxide. Then you divide this by 1 mole of carbon 3, hydrogen 8. Because what we're looking here is to cross these two. Since they are the same, you can cross them. And you have to multiply this number by this number. And the answer is going to be 10.95 moles of carbon dioxide. Now that we have all these, we are going to find the actual answer. That they are asking us how many grams of carbon dioxide. So we're going to look for the weight of carbon dioxide, and we have that you can see in your periodic table that carbon weighs 12 and that oxygen weighs 16, but since oxygen here has 2, you're going to multiply it by 2. So we have 12 here and 36 here, and you add it and you have 44. So 44 is the weight of carbon dioxide, and you have grams of carbon dioxide. Now we're gonna take the number up here, 10.95 moles of carbon dioxide times 44 grams of carbon dioxide divided by 1 mole of carbon dioxide. And you're gonna cross these two because they are the same. So you multiply 10.95 times 44 divided 1, and the answer is gonna be 481.8 grams of carbon dioxide. And this is the answer of our first problem. Problem number 2. They are asking us to calculate the percentage combustion of mass in carbon, hydrogen, and oxygen. And they give us this equation. So we know that carbon here we're gonna have 9, 10, and 1. And then in our periodic table we're gonna look for its weight, and we know the carbon weighs 12, hydrogen weighs 1, and oxygen weighs 16 because we are rounding it to 16. And now you have to multiply all these, and these will give you 108. Down here we're gonna have 10, and down here we're gonna have 16. Now you are going to add all these, and it's going to be 136. To find the percentage of these, we are going to take the number 108 for carbon divided 136. So you grab your scientific calculator and you divide these by these, and we are going to have 0.80. Then we multiply these by 100%, and we are going to have 80.6, because down here we had a 6 before, and this is going to be the percentage of carbon. Now we're going to take the percentage of hydrogen. So we take 10 divided 136, and this is going to give us 7.46%. What I did here is that I wrote it down in my scientific calculator and multiplied by 100. And now we're going to take oxygen and we're going to do the whole process all over again. It's going to be 16 divided 136. That the answer of these times 100%, and that is going to give us 111.94%. So this is a percentage of carbon, of hydrogen, and of oxygen. This is how we found the percent of combustion of mass of the cyanamic alcohol. Now the part B asks how many molecules of cyanamic alcohol are shown in one sample of 0.469 grams. So we write down here 0.495 grams of the equation up here. Now we're going to multiply these by 1 mole of the equation up here, 2 C9 H10 O. We divide this number by 134 grams, which is the number up here. 136 grams of C9H10. the same number as here. These we're going to multiply it by Avogadro's number, which is 6.022 times 10 to the 23rd. So you take your scientific calculator and do all these. These times these, divided this one, times the Avogadro's number, divided one more. And the answer is going to be 2.1077 times 10 to the 22. Molecules of So you always have to keep it in mind that the Avogadro's number is 6.022 times 10 to the 23rd. So what I did here is that these times these divided these times these divided these, and the answer was this. 2.1077 times 10 to the 22 molecules of carbon 9, hydrogen 10, oxygen.
Amen. It's a throwback. Hey. Now, I'm not trying to be rude, but here, pretty girl, I'm feeling you. The way you do the things you do, mind me and my Lexus cool. That's why I'm all up in your